Hi, class, and welcome back to Electromagnetism, our lecture. And we're going to talk about batteries and transformers today. And I hope that you're ready. So let's go ahead and do that. So, a battery is something that we take for granted all the time because we're always looking for batteries that try to make things a little bit easier with our day. And so if we think about batteries, we have our little. It's really a device that converts chemical energy into electrical energy, and so that's really what a battery is. And we have this pretty much. You can kind of like get a D battery. There's what? There's A triple A batteries. There's A batteries. There's D batteries, and I know there's like watch batteries, like little flat ones, and they all have a certain amount what we call a voltage, and that's one of the reasons why you get certain batteries that run certain devices. And so a battery is a device that converts, by the way, it converts chemical to electrical. And the reason it's chemical is because in a battery, if you ever had a battery blow up, which means that sometimes batteries get overheated and they start corroding and they leak out some fluid, and it's battery acid, and you don't want that battery acid on you because it's like it's acid to your skin. It burns, and it can get into your eyes, which is even worse. But you kind of want to really think about the way you dispose them in the garbage can. That's why sometimes that you have to be careful with them. They do corrode, and you have to clean that corrosion up sometimes, and that's why you probably heard like of Coca-Cola, like a cola that puts has that acid on and eats the corrosions away. You probably heard about that before, but we're not going to do that today. But what we're looking at is that inside our battery, there is these. They're kind of like waffles, not waffles, but they're very there's things going on to it, and I don't want to kind of go over this, but there is something inside that when you have it connected, it makes a current. And what it's doing, it's taking that stuff inside and make it into electrical to run your device. Okay. So anyway, so Volta, Aless, Alastro Volta, he's the one that kind of came up with the batteries of a battery. Really, if you think of volts, we take Volta, and you can do a little bit of research if you want on them, but it's not really important for us because we're doing just this basic rundown here. So let's take a long nail. And if you don't know what a nail is, I mean, there's all kinds of nails there. But if you take a long nail, and I mean, just, normal size, and if you take a power source like a battery, it could be like a 9-volt battery, it could be a 6-volt battery, it could be anything. And what you could do, if you take some wire, wire is like, that you find like copper wire, it could be metal wiring, it doesn't matter. And if you take that wiring and you go ahead and make a whole bunch of loops around the long nail, which is like a metal, right? So it's a metal. If you take some wire and put it in, just coil it around a nail or something long that's metal, and you hook one end up to the one terminal, and you hook up the other part to the end of the terminal. So you have this positive to negative part, right? And on the power source, I think it says negative and stuff like that if you look very closely. But what's going on is that you have some current because it's a completed circuit, and the battery is going around. The current's going around. And so what's happening as this when there's a lot of wire here, I mean many wirings that go around, maybe loop, they should call them like loops, right? Many loops. What's happening is that this is making what we call a magnet. It's making some kind of it makes some kind of magnetism. And so there's a magnetic field around this. And if you can try this at home, just be very careful because this gets very hot. And doing this in class, I usually do this, and it gets very hot, and I have to make sure I be careful with this because it can really burn you. But as you hook this up, and you have maybe like a paper clip or something like that, or maybe a staple, or even something a little bit more heavier than this battery, maybe you can make like a 12-volt battery. It becomes a lot more magnetic, and so this attracts a lot of stuff, but it gets very hot as it goes. So just be careful if you're going to do this at home. So anyway, according to this, that if the more loops you have, or the more coils that are around the metal, around the big nail, you have a lot more current. You have a lot more magnetism, actually, right? And so the point of all this is what I'm trying to get to is that the more wire, the more magnetic. Okay, magnetic. The less wire, less magnet. Okay. And if you go back to Michael Faraday, that we did a couple lectures ago, he talks about, as I'm putting a metal object through current, I can generate a magnet. And you can go back to Michael Faraday about this, right? But we've done that before. And so the whole point of this, what we're trying to come across is that from a battery standpoint, is that if you have a battery and you have some kind of wire, some current, you can make some kind of electronics that reduces or increases wattage. And here's what I mean by this. So our topic that we're going to look at a little bit more today is called a transformer. And a transformer, what this does, it converts energy from high or low to high voltage. Okay. And so if this is converting, is that you want to kind of be careful with this, because if you have, let's say you take your charger. So think about your charger, like maybe a phone charger, maybe a laptop charger, and you see this little long box kind of at the end of the cable, and the cable kind of goes out like this. And it's like I think it's like a black box if you think about it. It's on your chargers. Look on your charging of your laptop, or your charging on your cell phone. And what this is a transformer. It's just a small transformer. But the thing is, in the electric lines, you have about 110 to 120 volts of electricity that goes into your home. So that's the wattage into your home. But your devices, like your cell phone and all the electronics that you have in your house, don't run on this much current, this much AC current. These run on DC current, and all your devices run on DC current. And that charge, but your appliances don't, right? So your chargers have to, in order not to fry your cell phone, you don't want to fry your cell phone. Well, this will fry your phone in seconds. What you want to do is reduce this energy down to make the phone applicable to charge. And this is what these are. These are transformers on your cord of your phone. And so they convert higher to lower, lower to higher voltage, depending on that what you're doing. So if you're charging your cell phone, just say it's going to be a reduced. So it's going to go from high to low. But it can also go the other way around. Depends on what you're charging. So let's look at some transformers here. So here we go. So usually what they look like is that they have some wire, like a metal object or something like that, right? It's like a metal object, and it's like a piece of metal here, and they have a north and a south. And what this is that you take this piece of metal that looks like almost like a square if you think about it. And usually what you do is that, let's say you want to decrease voltage. Let's say you want to do this. You want to take your home voltage to your DC current, which you have to reduce it because you're going to fry it if you don't. So we want a decreasing voltage. And so here's the idea of this. So you have coming into this, if you want to decrease this, what you want to do is that, let's say you have some wire here. Let's say you have some loops of wire. You have some coils of wire. In order to decrease this, you want to go from increase to decrease. So obviously what you're going to do is that, are you going to add or subtract coils? And to do this, you want to lessen less. You want less coil on this side. So you want more coil here, and you want less coil here. This is what we call a decrease in wattage. What if you want to go the other way around? What if we wanted to increase the voltage from your home to one of your appliances at home? So for example, maybe like a hair dryer. A hair dryer uses a lot of current. And this is one of the reasons why you can blow fuses. You can blow fuses in your house if you have a dryer going, a hair dryer going, maybe a blender going. If it's on the same circuit, you can blow what we call fuses. And so let's say we wanted to increase voltage. Well, to do this, if you take this, so let's say we want less here, we want less coil. What do you think we're going to do? We're going to have more coil. And this is how you increase voltage. And this is a simple transformer. And that's all you're doing. You're just taking a metal piece, you're taking some coil to less coil, less coil to more coil. And what you're doing, you're increasing the more wattage, the more current that goes through that. So that's the idea here. And so here's the formula that we're going to have to work with on our homework and today. So let's say that our formula says, if we take the first voltage divided by, so this is the division, divided by the number of turns. What I mean by turns, this is the number of coils, like the coil turns. That's kind of what I did up here. These are the coil turns. So I call them, they call them turns in the book. And that's the first. So let's say that this part here was the first wattage, the number of turns here. This would be the second voltage to the number of turns or coils. So what you're doing is that you're trying to make the voltage decrease or increase depending on how many coils that you are putting around versus the second one, right? So here's the idea. Let's give you an example of this, and maybe this will help you along your way. And then this will help you answer your homework for a little bit. So let's say that we have 100 voltage and we have 100 turns. That we want to figure out how much voltage we're going to get, but we want 200 turns. So this is kind of what your idea, so your homework's going to be like. So we want to say, is this going to be an increase or a decrease? And can we figure out the voltage? So if you think about it, this is kind of like here, right? So when it comes in, you have 100 volts, but you have 100 turns. So you have 100 volts, 100 turns. That comes out to be voltage, don't know, but I have more turns than 100. I have twice the amount of turns. So you're probably thinking, okay, that's going to be a increase, right? Because you are going from less to more. So we're going to increase voltage. But I want to figure out what voltage you're going to have. So to do this, all you're going to do is just cross multiply. You're just going to cross multiply and solve for V. And if you don't like V, you can always put X. I know we're also familiar with just solving for X in math classes, but it works the same way. Okay, you're just solving for the variable. So here we go. So what if I just go ahead and cross multiply there? You can probably do this faster. I don't know. It depends on your math skills. But that's 100V equals, well, that's going to be 100 times that. I'm just going to go ahead and do this for you because I want you to see it, okay? And so you have that. Now, remember, you're just going to solve for the variables. So this is going to be 100V equals, well, that's going to be 1 times 2 with four zeros. So that's 2, 2, 1, 2, 3, 4. Just make sure I got my math right there. There's 4 zeros because there's 4 zeros there. So that's 20,000. Now, how do you get V all by itself? Remember, there's a multiplication there. You're going to divide. So you're going to divide by 100. You're going to divide by 100. Remember, what I do to one side, I do to the other side. Those cancel out. Those cancel out. I got just the volts. And if you want to put V2, maybe that will help you because you don't want to get this all cruddy up. Put V because it helps V2 to kind of separate the two, so you're not finding this because this might think about volts here, volts there. You want to be careful. Okay, and so here we go. So that goes bye-bye, that goes bye-bye, and it looks like you have 200. I think that's going to be volts. Yeah. If you can almost do this without doing the math, because you have 100 volts over 100 terms, that this is a proportion. Remember, this is a proportion. A proportion is when you have two fractions together that are equal together. So if you think of 1/2, that fraction is going to be 2/4. And then the other one would be, 4/8. These fractions are equivalent. And if you think about it, this is very easy to kind of calculate. So you don't really need a whole lot of math here. It's 200 volts. By the way, this math is very easy. So I'm not going to give you probably this much easy math here. You're going to have to do some solving. I mean, that's pretty straightforward. But the idea is that you're trying to cross multiply to solve for the one that you do need. And so now you know that, hey, I'm going from less to more. I need 200 volts of current to work with. And that's the idea of what you're doing with a transformer. Okay? So that's all we're going to do today. And I'm hoping that this works out. Just review. See you later.